Here are solutions to homework set number 12 for ECE 111. This homework set looks at using complex numbers. Now with numbers you've got real numbers and complex numbers. Real numbers work just fine when you're dealing with DC voltages, constant voltages. If a voltage like 3 volts, I can describe that pretty well with just a real number, 3. However, when you're dealing with a sine wave it's actually got 3 numbers. I've got the frequency, sine, and cosine. Frequency is not an issue. The frequency doesn't change on linear circuits like resistor, capacitor, inductor circuits. The sine and cosine do. So I need to have 2 numbers representing a sine wave, one for sine, one for cosine. That's complex numbers. So as soon as you start dealing with AC signals, you're going to be dealing with complex numbers throughout your time at NDSU. So that's kind of what this homework set's all about, getting used to complex numbers. Now, with a complex number, you've got 2 forms, rectangular and polar. In rectangular, I've got the real axis, the complex axis. So if I have a point, minus 7 plus j, that's minus 7 real, plus 1j complex, I can express that in rectangular form, minus 7 plus j1, or polar form. In Matlab, I can do that by inputting the number, minus 7 plus j. The magnitude is the amplitude, the angle is the angle in radians, times 180 over pi gives you radians. You can also use an HP calculator. Again, I kind of push the HP calculator. I think they're worth 10 points on a test, and I don't think that's an exaggeration. To do a number, minus 7 plus j, well, the way the HPs work, I have this key complex. That's how you input a complex number. So if I go modes, rectangular, I would have negative 7, enter 1, input the real part, complex part, then complex. There's your minus 7 plus j. Go to modes, polar, that's the polar representation, 7.07, add an angle 171 degrees. And if you prefer radians, I can go modes, radians, I prefer degrees. Take a second number, minus 1 plus j10. In Matlab, the amplitude, absolute value is the amplitude, angle is the angle. Or with the HP, again, if I go back to modes, rectangular, negative 1, enter, negative 10, complex. Going over to polar, that's 10.04 at minus 95 degrees. Or minus 1 real, minus 10 complex. Here's the amplitude, there's the angle, minus 95 degrees. I can go the other way around. Given a number in polar form, convert to rectangular. The real part is cosine. The j part is sine. Or we can also do that. This is technically 7 e to the j minus 125 degrees. So I have to convert minus 125 degrees to radians, because anything English is wrong, basic rule of thumb. Convert to radians times j, e to the j theta times 7 gives you the real part, complex part. On HP calculator, I go to polar form, input the number 7 at minus 125 degrees. There's the number in polar form, convert to rectangular, minus 4 plus j 5.7. Okay, problem 2 is adding complex numbers. So if I do that, I can do that in Matlab. Minus 1, minus 7i, that's another way to input a complex number in Matlab, plus 5 minus j, plus minus 8 minus 5i, put it all together, I get 2 plus j 13. On the HP calculator, the way you do that is switch over to rectangular form. 1, enter, negative 7, complex. 5, enter, negative 1, complex. Now HPs have a stack. There is no equals button. To add numbers, I put the 2 numbers on the stack. Now I can add them. Take the next number, negative 8, enter, negative 5, complex. This is called reverse Polish notation. It's actually really efficient. It's got a learning curve. Don't learn how to use this on a test. Once you figure it out, it's really fast, really useful. Next problem, adding numbers in polar form. I can do that in Matlab, input each number in polar form, add them all up, you get an answer. Or it's actually easier on an HP calculator. Let's go to polar form. Let's do 10, enter, -84. There's the first complex number, 5 at 79 degrees. Second complex number, add the two together. You get a complex number, plus 9 at 99 degrees, -99 degrees, added. Answer is 13.9 at -87 degrees, or if you like rectangular, 0.59 minus J13. And one of the reasons I really like HP calculators, they give you the right answer. I've been teaching for 35 years now. I've seen many times students get the problem set up correctly, but they get the wrong answer. The problem is your calculator. HPs give you the right answer. That's worth points on tests. Next one, do this calculation. In Matlab, I will be almost the way you type it, 1 minus J7 times 5 minus J divided by -8 minus 5J, get a complex number. Now, this is a good test for your calculator. If your calculator can't do this, you need a new calculator. By the time you get to Circuits 1, you'll be doing problems like this. So on HP, that'd be 5, enter -7. First complex number. 5, enter -1. These are set up on the stack. I can now multiply. -8 minus 5i. Now this is the numerator, denominator, take the ratio. There's your answer. Problem 4. Figure out this problem. In Matlab, it'd be the way you type it. Using lots of parentheses never hurts. So there's 7 minus 8i divided by -20 minus 5i plus 6 minus I over 8 minus 6i. Figure that out. Take that result, multiply by 5 minus 7i divided by -7 minus 7i. You get a complex number. Okay, so try that with your calculator. With an HP, it actually is pretty easy. I do 7, enter -8, complex, -20, -5. Take that ratio. Next one, 6 minus J, 8 minus 6J. Take that ratio. Now here's the first result, second result. Add those together. Multiply by -5, -7, -7 plus J7. Take that ratio. Take that result, multiply. 0.678 plus J.1556. Problem 4. Now these you don't really do quite as often, but it is a perfectly valid operation. I can have e to a complex number. The result is a complex number. In Matlab has no problem with complex numbers. HPs have no problems with complex numbers. So 2, enter 1, complex, to e to the x, you get a complex number. Take -7 plus J7. Take the log of a complex number. The answer is a complex number. Now in Matlab, log is natural log, log 10 is log base 10. On an HP, natural log is ln, log is base 10. I can take a complex number raised to a complex number. So 2 minus J3, 3 minus J2, that's the y to the x. I'm going to take y to the x power. So here's y to the x power. And it's a complex number. What that means, I actually have no idea. But again, take a complex number, do an operation, you get a complex number. Last two problems, partial fractions. Now this is something you do all the time in electrical engineering. I've got a function like this. I want to split it up into its parts. Now the way partial fraction works is equals is really powerful. It means these two sides are exactly the same everywhere. So let's take the point minus 1 minus 4j. This term goes to infinity. This is a constant. A constant relative to infinity doesn't matter. So as I let x go to minus 1 minus j4, this goes to infinity times a constant. This goes to infinity times a constant. Covering up this term, that constant must be this as x goes to minus 1 plus j4. That's called the cover-up method. To do that, here's kind of a trick. I'm going to take minus 1 minus j4, negative 1, negative j4. I'm going to store it in a variable called x. So if I do store, there's no x's currently. I'll do alpha x. I've got the variable x, and create other variables y. Let's do a variable y. I would do store alpha. Here's where y is located, and there's y. Now I've got these variables x and y. What I can do with that is anytime I want to pull up x, that's x, save some typing. So to evaluate this at x equals minus 1 minus j4. So take the number 3, x plus 1. So here's recall x, 1 plus multiply, times x plus 2, recall x, 2 plus multiply, divided by x plus 1 minus j4, recall x, 1, enter, negative 4, complex, there's your 1, minus j4, add it to x, divide, divided by x plus 5, recall x, 5 plus slash. There's my answer, that's A. Let's do that for B. For B, I could do that in Matlab. Just cover up this guy, analyze at x equals minus 1 plus j4, plug it in, I get 0.93 plus j.56. If you're doing a homework set, that's fine. On tests, you don't have access to Matlab, so you need a calculator that can do that. So let's do minus 1 plus j4, store that in x. Now analyze 3, recall x, 1 plus times, recall x, 2 plus times, there's the numerator, divided by x plus 1 plus j4, recall x, 1, enter, 4, complex, plus slash, divided by x plus 5, recall x, 5 plus slash, there's the second answer. Can notice the HPs did that pretty easy. If you have a Sharp calculator, TI calculator, good luck. This is much faster. On tests, speed matters. Speed is worth points. You got to get through the whole test in 1 hour. Getting the right answer matters. Okay, that's kind of why I say HP is worth 10 points on a test. And then the last problem, did that. Find the partial fraction expansion for this. Again, to find the A term, I'll do the cover-up method. Cover up this term, analyze at x equals minus 1, and that's A. So x is minus 1, plug in everything else, I get my answer. On an HP calculator, same thing we did before. To get B, I will use the cover-up method. Cover up this term, analyze at x equals minus 3. So x is minus 3. Plug it in, I get minus 4. Likewise for C. Likewise for D. So that is homework set number 11, is practice using complex numbers. Again, once you get through, about halfway through circuits 1, you stop dealing with DC signals, you start dealing with AC signals. Anytime you're dealing with AC signals, you need to be using complex numbers. So about halfway through circuits 1, you switch from real numbers to complex numbers. From then on, you'll be using complex numbers throughout your time at NDSU. So likewise, you need a calculator that can do complex numbers. Your pick, whichever one you use. But whatever calculator you use, make sure it can do complex numbers, make sure it can solve problems like this homework set. You'll need it when you get to circuits 1. That is homework set number 12 for ECE 111.